So as we finish up today's lesson, on accommodation, we're looking at how the eye changes in order to adjust to the conditions outside. So for instance, when it gets really bright out, it changes the size of the pupil by the iris contracting or relaxing. That lets in more or less light as needed. Well, when objects are too close or far from the eye, then the ciliary muscles pull on the lens to change shape as needed. Now, those two types of accommodation occur in the eye to adjust to the conditions outside. But your brain also helps a lot with accommodation. Not only does it help do this adjustment for pupil dilation and lens contraction, well, it does that all on its own, but it does another thing. At the back of your retina, we know there's rods and cones. Those are special light-sensitive cells that get excited when light hits them. However, this spot where the optic nerve attaches to the back of the eyeball, there can't be photosensitive cells on that. That's where all the information is getting sent up to the brain. That creates a dead spot on the back of your retina where even if light hits it, your brain can't pick it up. There's no photosensitive cells there. Just like light hits my arm, but it has no photosensitive cells, so my brain doesn't go like, oh, great, my arm is looking at the table, right? So our brain has to take into account that both our left eye and our right eye have this little tiny spot in our vision that has no cells. So there's a few ways our brain accommodates for this. First off, when you and I are just walking around, we probably have both eyes open. And as a result of having both eyes open, well, the right eye's blind spot, which is right about here-ish on me, a little bit to the right of center, and the left eye's blind spot, which is a little bit to the left of center. Well, my right eye can see my left eye's blind spot, and my left eye can see my right eye's blind spot, and we're usually good. So with both eyes open, I can't look around my kitchen and see any gray, fuzzy areas. So what exactly does your blind spot look like? Well, it's kind of hard to describe, guys. So I'm going to have you find your blind spot in your right eye. So what I want you to do, close your left eye. Your left eye would normally have accommodated and seen the blind spot for your right, so we have to close the left eye. And you're going to keep your head still. And what I want you to do is focus closely on each of the letters and note whether or not you can see that black dot on the right side of the screen. Now, pause the video, and what I want you to do is keep track of how many letters cause the dot to disappear and how many letters that you can still see the dot for. This actually gives you an approximate size of your blind spot. So pause the video. Do it. Pause the thing. Now. Okay, depending on how far you put your screen to your eyes, that blind spot might be large, meaning the number of letters that you were looking at that caused the black dot to disappear might be large if your screen was very close to your eye. Now, can you describe what the black spot looks like when it's gone? Ooh. It's physically still there though, right? We know physically that that is still there, that symbol, but we can't see it because that light is entering the eye, falling on the retina, hitting where the optic nerve meets the back of the eye, and so that light isn't being transferred into signal that goes to the brain. Now, you can continue accommodating in different ways. Now let's try the same thing. So I want you to cover your left eye, look at each of the letters in turn, and when the black dot disappears, what do you observe in that spot? Think about it for a second. You can pause the video if you need more time. Did you see how that black spot not only disappears, but your brain fills it in with the color that's behind it? Well, that's because our brains have evolved to pattern recognize. That's one of the big advantages of having a big brain is our ability to recognize patterns like this one. Even if I had a blind spot in a room full of detail, and this black line is going to be used to be an example of detail, if I close my left eye and look at the letter B, the black spot goes away for me, but I see green with a black line in the middle. Your brain is so good at pattern recognition, it fills in the blanks. One of the reasons you've never actually noticed your blind spot without actively looking for it is that your left eye can accommodate for your right, and that your brain fills in the blind spot with the patterns it sees behind it. As a result, it's not a thing that you can easily notice in day-to-day life, which is exactly what we want our brain to do. Fun fact, it does accommodate for the fact that you see your own nose. Your brain just drops that information because it's unimportant and you see it all the time. So that is the end of the accommodation part of today's lesson. Finish up the last few questions, your review at the end, and you are done. Monday, done. All right? Have a great day, guys.